Hi everyone, I'm James, M0YOM, and welcome to part 2 of my station audio design. It's been a little while since the last video, but I'm hoping to get into a bit more of a regular upload schedule from now on. So, following on from the last video, where we started talking about the station audio design, in this episode we're going to be looking at the problem we introduced of ground loops. So, just what is a ground loop? Put simply, a ground loop is a conductive loop that occurs when two or more components, each with different connections to ground, are interconnected. We can illustrate this with a simple diagram. We have three separate devices, each connected to ground, and each with a ground connection to the next device. If you're not familiar with the concept of ground loops, then it might not be immediately obvious where the problem is here, but if we imagine ground as another connection in the circuit, we can much more clearly see where the loops are formed, here, and of course here. Ground loops can occur in almost any device that has a ground connection and a connection to another grounded device. In our case, it's audio equipment, but they can also occur in your station grounds, in computer connections, perhaps where you have a rig connected via a COM port with your computer, even in the circuit design of a piece of electronics, although that's a little beyond the scope of this video. But why is this such a problem, you might be wondering? Well, ground loops can cause a whole variety of issues, especially when we're talking about an amateur radio station. They can cause hum and buzz in audio from 50 or 60 hertz pickup from your main supply, and this includes harmonics. This is the classic mains hum in speakers or headphones that some of you may be familiar with. They can cause RF pickup in your audio. Ground loops can turn your cables and devices into antennas, which is especially important in an amateur radio station, so they can lead to RF getting into your devices. Often this can appear in your audio, but it can also manifest in other ways, which we'll cover in a moment. They can cause loss of dynamic range in audio systems. They can cause RFI in your receiver. If you're QRO, especially if you're running an amplifier, they can cause RF to get into your devices to such an extent that the current flow on the cables, chassis, or microphones can lead to shocks, which is not a good thing. I've experienced this myself, and it's not pleasant to get an RF burn off of the chassis of a piece of equipment. They can lead to reduced antenna efficiency. Ground loops on coax shields can create unwanted common mode currents, which can detune antennas. They can lead to a raised noise floor, which in turn will reduce your receiver performance as weak signals get lost in the noise. And in some circumstances, the RF getting picked up due to ground loops can lead to equipment getting damaged. Now, this certainly isn't an exhaustive list of all the problems that can be caused by ground loops, but I'll consider these to be the main ones, especially where an amateur radio station is concerned. So how do we go about fixing the problem of ground loops? There are basically two main approaches. We can eliminate the ground loops. This is by far the best option, and wherever possible, it's what I'd recommend. Or we can sometimes treat or manage the effects of the ground loops. Elimination of ground loops is always the best approach, but this isn't always possible, so we do sometimes have to find ways of managing their effects. Essentially, there are two ways that we can eliminate the ground loops. If we take another look at our diagram from earlier, we can change the grounding system to a star or single point ground like this. This results in only a single ground connection for all devices. Typically in a station ground, this is the approach that you should take, with a single ground bus being used for all connections. With our audio system, however, we're primarily dealing with the safety ground found in the mains electrical supply, so this isn't an option. It should go without saying, but you should never, ever, ever mess with the electrical safety ground. It's there for a very good reason, to keep you safe. There are even some commercial products out there aimed at the audio market which deliberately break the safety ground. Don't use them, they aren't safe, and your safety isn't worth jeopardising. It can lead to electrical shocks, fires, and injury, and potentially worse. What we can do instead is break the ground on the connection between the devices. We'll pop over to the bench now and have a quick look at some of the devices that we can use to achieve this. Right, we're over on the bench now, and we're going to take a look at three different devices that we can use to help eliminate ground loops in our station. The first, and by far the cheapest, is a small inline ground isolator. This takes a 3.5mm jack on both input and output and breaks the ground connection between those two devices. I've used these for a number of years with a great deal of success, and they're very cheap. I think I paid about £6 or £7, so around $10 for this one, just from Amazon.
and I'd definitely recommend these where they're applicable. In my new station, though, I'm going to be using balanced XLR connections. So these small inline isolators won't maintain the balanced connection between the devices, so we can't really use these in my station. Instead, we're going to use one of these. So this is a line isolator. It's specifically designed for professional audio use. There are plenty of these out there on the market. This particular one is an IC1 Ice Cube. It takes a balanced XLR connection on both the input and the output. And importantly, it provides electrical isolation between them. So there's a small transformer in here that electrically isolates the two devices that connect through it. It's also got a little button on here called ground lift. And what this does is it allows us to break the ground connection between the two devices and therefore breaking the ground loop. Now, for the microphone connections, obviously the IC1 Ice Cube is absolutely perfect. But for some of the connections between the rigs and the mixer, where we want maybe the speaker output from the rig to go into the mixer and the output from the mixer to go back into the rig, we can't really use the line isolator because there's an impedance mismatch. So we're going to use something called a DI box instead. Now, there are lots of different DI boxes out there. They're very similar to a line isolator in the way that they work, but they specifically provide impedance matching, and the one that we're going to take a look at here also allows me to take a speaker output and feed it into a line in on the mixer without any danger of damaging it. So this one is the Ultra DI Pro, the DI, I think it's the 4800 from Behringer. It's actually 4 DI boxes in the one chassis, which provides all the connections that we need. And much like the line isolator, we have inputs on the back. This will take balanced or unbalanced inputs, and it gives us a balanced output on the front. And importantly, if my camera will focus, there we go, it also has the ground lift button, which is what we'll be using in order to break those down ground loops. Now, you don't necessarily need something as large as this. A DI box you can also get in a small form factor like this. It's only because I happen to need 4 of them. There's 4 in the one chassis, and it just provides a nice way of mounting it for me. All right, let's head back over to the computer, and we'll take things from there.
So as I mentioned earlier, sometimes it's not possible to eliminate all the ground loops, but there are some things that you can do to reduce their effects. You can try to make sure that all mains powered devices are connected to a single electrical socket, typically through the use of a multi-gang socket adapter. This can sometimes help, especially with audio ground loops, but remember, you must take care to ensure you aren't overloading the socket. We can use balanced or differential connections between devices. These help to reject common mode noise that can be caused by ground loops. Ethernet is a common example of a differential connection. In the case of audio, a balanced XLR connection, where possible, is the preferred choice, and it's what I'll be doing in my station. In some cases, filters can be used to block, say, 50 or 60 hertz hum, or sometimes RFI. Chokes can be used too. These are very common on coax runs on certain types of antennas, but they can also be used anywhere where common mode currents are an issue. We're all probably familiar with the snap-on ferrite beads that are usually found in many a hand shack adorning the cables. It's also worth pointing out that not all ground loops will cause issues. So whilst it's always a good idea to try where possible to eliminate or manage them, sometimes you don't have to. In my station, I know that the ground loops in the audio equipment do cause me problems, so it's something that I have to address. But many of them outside of the audio devices don't cause me any issues at all, so I don't need to do anything to address those. By this point, you should have a pretty good idea about ground loops and how they can be dealt with. Let's take a look back at the original audio design schematic for my station. If we add in the grounds for the equipment I'm experiencing issues with, we can see that there are a number of ground loops that exist, primarily these. We can now incorporate the DI boxes and the line isolators into the design in order to eliminate those ground loops. As you can see, we now have the Behringer DI 4800A and the IC1 Ice Cube line isolators that we looked at earlier sitting between the rigs and the mixer. And using the ground lift feature on these, they can work to eliminate those ground loops. Additionally, the Behringer also provides some other features like impedance matching, because I'm taking a speaker output and feeding it into a line in effectively, and the line isolators also provide electrical isolation between the mixer and the microphone inputs on the radio. So in future videos, we'll be going through setting all this up, building everything that's in the design, as well as setting up and configuring the mixer. So are there any other solutions to ground loops that I haven't covered? How have you dealt with them in your station? Let me know down in the comments, and if you've got any questions, suggestions or ideas, I'd love to hear them. Remember to like, subscribe and hit the bell icon so you get notified about future videos. Thanks very much for watching, and I'll see you in the next one.